Hi there, my name is Magdalena Kersting. I am an assistant professor of science education at the University of Copenhagen in Denmark. And today I will talk about the use of virtual reality in astronomy education. So this is joint work, first of all, with Jackie Bondell, Rolf Steyer, and Mark Myers. Both Mark and Jackie are affiliated with the Australian Research Council Centre of Excellence for Gravitational Wave Discovery, which is a really long name, and this is why we just call it OSGRAV. OSGRAV has a dedicated education and public outreach team, which I will abbreviate with EPO. And at the end of this talk, I will also link to the OSGRAV EPO resources, and all of the resources I will mention in this talk and the nice screenshots of virtual reality experience that you're going to see all come from the OSGRAV team. And the talk is based on a recently published paper. It's an open access paper, so you can read it, access it, and find it in the International Journal of Science Education, Part B. So my idea for this 10-minute talk today is that we will first talk a little bit about the motivation of this particular study, then look at the methods and briefly look at our findings. So if we start with the motivation, obviously virtual reality technologies offer really exciting opportunities for enriching astronomy education. And I'm sure all of you can imagine many different ways in how virtual reality could enhance, enrich, support astronomy education, in particular in informal learning environments. And I will not dive into details of all those opportunities. Instead, we shift the focus to the often neglected perspectives of astronomy EPO professionals, because these EPO practitioners and professionals are the ones who come up with the ideas for virtual reality experiences, design them, then just design them for particular contexts. They might facilitate them. So there's a lot of expertise, a lot of knowledge that is tested that goes into the design and use of these virtual reality environments, and that are usually not really being promoted or given voice to. And this is what we wanted to change in this study, obviously to support anyone who wants to use virtual reality in astronomy education. We had 3 research questions. What characterizes the motivation of EPO professionals to use virtual reality in astronomy education? The second one is, which opportunities and challenges of VR astronomy education guide the development and facilitation of VR astronomy experiences? And finally, reflecting on the findings from those first 2 questions, so the motivation of EPO people on the one side, and all the opportunities, but also challenges of virtual reality on the other side. And if we bring those 2 together, what design principles can we formulate to develop and use virtual reality to improve astronomy education practices? And another motivation for me personally is that I think through this work, we also contribute to bridging the gap between research and practice in astronomy education, which is always a good thing. So our methods, first of all, I need to say that this study is interdisciplinary and we incorporate perspectives from astronomy, obviously education, research, and design. And to help us really combine those perspectives and get the most out of them, we drew on work by Donald Schoen called a book called The Reflective Practitioner. And the idea of reflective practice can be divided into 2 separate ideas. We have the idea of reflection in action, that is thinking and reflecting while you're doing something, maybe running a virtual reality experience. And then there's reflection on action, which is thinking and reflecting after having done something, after having facilitated a virtual reality experience, let's say. And we jointly engaged in an active reflective practice, both in-action and on-action through joint dialogues between two education researchers and two practitioners. And this is what I want to focus on today. More broadly, we employed a two-step analytical approach involving thematic analysis of focus group interviews as our first steps and reflective dialogues as our second step. So the first step, we had two semi-structured focus group interviews with EPO professionals and astronomers, all coming from OSCRAF. We employed thematic analysis, deductive coding to really be able to answer our first two research questions. I think the second step is the more interesting one, so I'm going to focus on this one. Building on the findings from the thematic analysis, we engaged in two reflective dialogues. So we were two education researchers, two EPO practitioners, and these reflective dialogues or conversations had the goal to be able to formulate design principles for virtual reality astronomy education and really unpack what goes into the design and use of virtual reality environments. So I'm going to focus on step 2, but if you want to read more about step 1, you can either read the summary for this workshop or just go straight to the original paper. So let's look at the findings. We tried to condense our conversations into neat design principles, obviously, and we used a framework for virtual reality and astronomy education that consists of 4 features: immersion, visualization, collaboration, and facilitation, which each are important aspects of virtual reality environments. And I think I'll just quickly go through each of them to give you an idea. And the first one, design principles for immersion. I think immersion is what most of us will associate with being in a virtual reality environment. And here you can see a video of the virtual reality environment Cyber, Science and Virtual Reality, developed by the OSCRAF team. And something that the designers and developers from OSCRAF told us was that you need to be really careful to not overwhelm participants while they are in the environment. So they are not just watching something, but they are really in the environment, and this can easily become overwhelming because there's so much sensory input coming in. And something that we learned is when you move in this environment, or you have the environment move, the question is, okay, is the participant actually getting a sense of moving? So are they moving themselves, or is the object moving further away? Or is the object maybe getting smaller? So there's a lot of movement if you find yourself in the environment, and just being really careful of not overwhelming participants and being really conscious of just simplifying the experience to make most of it. If you look at design principles for visualization, here I have a picture of a binary star system, neutron star and a pulsar. And if we look at our design principles and principle 2, it's so important to make clear when representations are scientifically accurate and when artistic freedom is required to communicate an idea. And what we can see here is obviously the OSCRAF team employed some artistic freedom to illustrate this. And this is a direct quote from our conversation, where one of our EPO practitioners said, things like magnetic radiation that's outside the visual range, radio, X-ray, and then gravitational waves. How do you portray that? Because you still need to portray them. And here you can see that both the pulsar emissions, like you wouldn't see them normally, and here they are illustrated with these semi-transparent blocks of color. And then there are also the visualizations of the orbits to help illustrate a scientific idea, although these things are obviously not visible to the naked eye. If we look at collaboration, I think that's a particularly exciting feature of virtual reality environments that the OSCRAF team has really employed well and is building on it. And they use it through two design principles to use screencasting to foster collaboration. And on the left-hand side here, you can see several people being in a virtual reality environment. And here in the screencasting, a facilitator can see where each of the participants is in the environment and really see what's going on and help them. And the other one is that we can treat virtual reality experiences as group activities. And this is the picture you can see here. This is an excerpt from our dialogue, and I'll just read it aloud. So, for example, the Mission Gravity school incursion, students are working in teams. One of them has to write down what the other person is collecting, the data that they're gathering. There's that communication where one is gathering the information and seeing it and then verbally relaying it, and the other one needs to record it. And then it's kind of funny what happens when the students work in groups with the Mission Gravity. You sometimes see it if kids are taking turns with a guided tour, then one has already been in the virtual reality, they become a leader for the next person. So they take over, telling them what they're seeing or guiding them on how to do it. So it's a collaboration piece, which I think is the first person to go, then empowers them with a little social group to be the new expert. So here, Mission Gravity, which is one of the virtual reality programs that OSCRAF developed, is designed in a way that the students are empowered within their little social groups. It's a group activity and a student can't really do it on their own. And now I'm afraid I'm running a little bit out of time, so I will skip over the idea facilitation, but of course you can stop the video and take a look at those slides and what I've just shared and written here. To summarize, those design principles can hopefully serve as guidelines for everyone involved in astronomy education and public outreach who want to use virtual reality. And I think we made two contributions in this study towards bridging the gap between research and practice in astronomy education. On the one hand, an empirical contribution where we have turned our attention away from the participants in the environment because there's much research already been done on it, and focusing on the EPO professionals who are actually developing and designing these activities. And the second contribution is a methodological one where we have demonstrated that education researchers and EPO practitioners can really jointly engage in acts of reflective practice. And this is a meaningful activity to do because we learn from each other and are able to gain new insights. So our reflective approach has led to rich dialogues and explorations of how the content, the pedagogy, and the technology intersect in virtual reality astronomy education. If you want to learn more about it, I just suggest you check out my homepage, which you find the link to here. I have also a newsletter where you can keep up to date. And finally, here are some references where you can check out our papers and importantly, check out the OSCRAF resources. Thank you so much.